Hello everyone, I am Dr. Janavi Chakrabarti. Today in this video, I am going to discuss the trapezoidal rule. Now let us first see what is the trapezoidal rule. The trapezoidal rule for estimating definite integrals of the form I equal to integration a to b f of x dx, which uses trapezoids to approximate the area under the curve. So we know that the definite integrals, it represents the area under the curve. Now look at here, in this graph, this is the function f of x, this is the curve, and this is the point A and this is point B. These are limits. Now we are dividing this interval a comma b into sub-intervals, which are x0, x1, x1, x2, x2, x3 and x3, x4. And these are the trapezoids. And we will approximate the area under this curve f of x using these trapezoids. We will derive this trapezoidal rule by putting n equal to 1 in the Newton-Cotes quadrature formula, which is given by this integration x0 to xn f of x dx is equal to n into h y0 plus n by 2 first forward difference of y0 plus n by 12 2n minus 3 second forward difference of y0 plus n by 24 n minus 2 whole square third forward difference of y0 plus so on. So the trapezoidal rule is given by integration x0 to xn f of x dx is equal to h by 2 y0 plus yn plus 2 into y1 plus y2 plus so on plus yn minus 1. In other words, you can say this is equal to h by 2 first term plus last term plus 2 into rest of the terms or remaining terms. H by 2 sum of the first and last term plus 2 into sum of the remaining terms. Here note that there is no restriction for the number of intervals in trapezoidal rule. We can use any number of intervals in this rule. So let us first see how to derive trapezoidal rule using this Newton-Cotes quadrature formula. So now you can see that this is the Newton-Cotes quadrature formula, which is given by integration x0 to xn f of x dx is this expression. Now we will put n equal to 1 in this equation and we will take the curve through 2 points which are x0 y0 and x1 y1. Since n equal to 1, there will be x0 and x1 points only and corresponding y values will be y0 and y1, and it will be a polynomial of first order. So the higher order differences will be 0. So second order forward difference onwards, it will be 0. Now if we put this in equation 1, what we will get? We will get, therefore 1 implies integration x0 to x1, because we are taking only 2 points, f of x dx is equal to n is 1 into h, and here it will be y0 plus n is 1 by 2 first forward difference of y0 and second forward difference onwards it is 0, so all the terms will be 0. So we are getting this one. Now this will be what? This is h y0 plus 1 by 2. We know that forward difference of y0 means y1 minus y0. Thus we are getting h 1 minus 1 by 2 y0 plus 1 by 2 y1. It will give you h 1 by 2 y0 plus y1. So we are getting h by 2 y0 plus y1. Similarly, if we take x1 and x2 points, we will get h by 2 y1 plus y2. If we take x2, x3, we will get h by 2 y2 plus y3. Similarly, if we take x1 to x2 f of x dx, we will get h by 2 y1 plus y2. x2 to x3 f of x dx, we will get h by 2 y2 plus y3, and so on xn minus 1 to xn f of x dx h by 2 yn minus 1 plus yn. Now we know that definite integrals are additive over subintervals. So if we add all these subintervals, we will get, therefore adding all these intervals, we get integration x0 x1 f of x dx plus integration x1 to x2 f of x dx plus so on integration x n minus 1 to xn f of x dx is equal to h by 2 y naught plus y1 plus for the second one h by 2 y1 plus y2 and so on h by 2 yn minus 1 plus yn. Now this side this will become integration x naught to xn f of x dx, and this side we can take h by 2 as common, y naught y1 plus y2 plus yn minus 1 plus yn. Now what we will get, h by 2 we can combine y naught and yn together, y naught plus yn, and all these terms are y1 plus y1, y2 plus y2, then yn minus 1 plus yn minus 1. All this term will be appearing twice. So it will be 2 into y1 plus y2 plus so on yn minus 1. So this is how we derive the trapezoidal rule. This is the trapezoidal rule. Sum of first term plus last term plus 2 into sum of the remaining terms. Now let us solve integration using trapezoidal rule. So now we need to solve integration 0 to 5 dx by 4x plus 5 by trapezoidal rule, and here ordinates are given which are 11. Note that k ordinates means k minus 1 subintervals. Okay, here a equal to 0, b equal to 5 and n equal to 11 minus 1, that is 10. Now we know that the step size h is given by b minus a by n. So we will get 5 minus 0 by 10, 1 by 2, that is 0.5. Also y equal to f of x is equal to 1 by 4x plus 5. Now we need to find the x and y values. A equal to 0 means a equal to x naught, which is 0. x1 is x naught plus h, so 0 plus 0.5, that is 0.5. x2 is x1 plus h, which is 0.5 plus 0.5, 1. Likewise we will get x3, that will be 1.5, x4 that will be 2, x5 that will be 2.5, x6 that will be 3, x7 3.5, x8 4, x9 4.5 and x10 5, which is b. Okay, like this we need to find the x values. The values of x and y are given below. These are x values, these are y values. Look at this table. We had y equal to 1 by 4x plus 5, right? This is the function which was given to you. So now x values we know 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5 and 5. If you use calculator for 0, we will get, we need to put it here. So for x equal to 0, what you will get? 1 by 5. 1 by 5 is 0.2. Likewise, you need to put x equal to 0.5, you will get 0.1429. Same way, if you put 1 there, what you will get? 1 by 9. 1 by 9 is 0.1111. This is the way we find y values for this given function. Now let us put these values in the formula. Therefore, by trapezoidal rule, we know x naught xn f of x dx is equal to h by 2 y naught plus yn, first term plus last term, plus 2 into sum of the remaining terms, y1 plus y2 plus y3 plus so on plus yn minus 1. These are the y naught, y1, y2, y3, y4 and so on. Here x is from x naught to x10 f of x dx. H by 2 y naught plus y10 plus 2 into y1, y2, y3, y4, y5, y6, y7, y8 and y9. Now let us put the values. Therefore, x naught is 0, x10 is 5. F of x is 1 by 4x plus 5 dx. H is 0.5 by 2, y naught is 0.2, y10 is 0.04 plus 2 into y1 0.1429 plus 0.1429 0.1111 plus 0.0909, which is y3. y4 is 0.0769, y5 0.0667, y6 0.0588, y7 0.0526, y8 0.0476 plus y9 0.0435. This is how we need to substitute the values. If we calculate it in calculator, we will get 0 to 5, 1 by 4x plus 5 dx is equal to 8.1100. So this is the answer. Now let us look at this problem. Here we need to evaluate integration 0 to 1, 1 by 1 plus x dx using trapezoidal rule. Here the number of subintervals are not given. As we know, in trapezoidal rule we can take any number of subintervals. So here let us take this number of subintervals n equal to 6. Let number of subintervals n equal to 6. Here a is equal to 0, b equal to 1, and therefore h will be equal to b minus a by n. That means 1 minus 0 by 6, 1 by 6. Also f of x is equal to y equal to 1 by 1 plus x. Now let us make the table for x and y values. The values of x and y are given in the following table. So x values are starting from 0, 1 by 6, x1, this is x0, this is x1, x1 means x0 plus h, so it will be 1 by 6, x2 will be 2 by 6, x3 will be 3 by 6, x4 will be 4 by 6, x5 will be 5 by 6, and x6 will be 6 by 6 equal to 1. So this is x3, x4, x5 and x6. Here y is equal to 1 by 1 plus x. If you put x equal to 0, it will be 1 by 1. So that is 1. For this you need to use calculator and we are getting these values. Now we will substitute these values in the trapezoidal rule. This one is y0, this is y1, this is y2, this is y3, y4, y5 and y6. Now let us use the trapezoidal rule. Therefore, by trapezoidal rule, we have integration x0 to xn f of x dx is equal to hy to first term plus last term plus 2 into y1, y2, y3 plus so on yn minus 1. Here we have x0 to x6 f of x dx h by 2 y0 plus y6 plus 2 into y1, y2, y3, y4 and y5. Now let us substitute the values. What is x0? x0 is 0, x6 is 1, 1 by 1 plus x dx is equal to h is 1 by 6 into 2, y0 is 1, y6 is 0.5 plus 2 into what is y1? 0.8571 plus y2 is 0.75 plus y3 is 0.6666 plus y4 is 0.6 plus y5 is 0.5454 and y5 is 0.5454. Now if you calculate this in calculator, you will get 0.69485, which is the required answer, and this is how we need to evaluate the integration using trapezoidal rule. Thank you.